Greetings to you all grade 11s and grade 12. I hope you all good. And in this tutorial, we're going to talk about Euclidean geometry, whereby I'll be specifically showing you how to prove theorem number 1 as a start. Of course, if you need some further assistance regarding mathematics, do not hesitate to hit me on my email above or the number above as well. So boys and girls, stay with me until the end of this video, since I'll be giving you some basic introductions that you might need when you apply the proof or when you prove the theorem. Let me take you through it in detail. Theorem number 1 states that the line from the center of a circle perpendicular to a chord bisect the chord. The line from the center of a circle perpendicular to a chord bisect the chord. Just in short, we're talking about a line from center perpendicular to chord. But it is quite important for you to memorize the whole entire statement, because they sometimes omit the key words through it, requesting you to fill in. So you need to note that. On your exam room, you will be given the drawing together with the statement. As you can see here on my left hand side, I am given the drawing together with the statement. On top, given OM perpendicular to AB. Prove that AM is equal to MB. So you will need to put into considerations that when it's come to these letters, it is not all about OM perpendicular to AB, and it is not all about AM equal to MB. They can use different letters here, so just go with the letters that are given at that particular time. So at the moment, I am going to use these ones that you are seeing here. So what you need to do when you apply the proof as the first point, you need to do the construction. So the construction for this theorem, let me write it down. Construction. On our construction, we have to draw OA and OB. Okay, we have to draw OA and OB. You are just joining them by dotted lines, right? Do not draw it as a line, just indicate as a dotted line, because it's the constructions. We're talking about the construction lines, must be indicated on a dotted line. I am done constructing. I constructed the line OA and OB. So after construction is the proof. So in order for this AM to be the same as MB, triangle AOM and triangle OMB must be congruent to each other. You will remember that when we talk about congruent triangles, we have got 4 conditions, right, to prove whether two triangles are congruent to each other. So let me emphasize the point here. In triangle OAM and the triangle OBM, these are the 2 triangles that I am going to prove that are congruent to each other. Okay, let's start with the proof. As you can see, on my triangle OAM, I am given the angle M1, which is equal to the 90 degrees. All right. On my triangle OBM, I am given M2, which is also equal to 90 degrees. As a result, M1, it is equal to what? To M2, right? The reason being, it is given. Done. Then number 2, OA, it is equal to OB. OA on our triangle OAM and OB on our triangle OBM. They are equal. The reason being, these two lines are representing the radius of the circle. A line drawn from the center of the circle to the circumference of the circle is a radius, right? So these two lines, OA and OB, are representing the radiuses of this circle. So the reason here you're going to write their radii, because are representing the radius. Number 3, OM, it is common. As you can see, the triangle OAM, it is having the line OM. Also the triangle OBM, it is having the line OM on it. So as a result, we're going to write OM for this triangle, it is equals to OM for this triangle. The reason being common. So finally, we will conclude that the triangle which is OAM is congruent to triangle OBM. The reason being is the right-angled hypotenuse sides. This is one of the conditions of our congruence. Right-angled hypotenuse side. Okay, so some of people, they can say it is what, because we have got two sides and one angle, they're gonna say this is a angle side or side angle, right? But even that, it is correct, guys, but I prefer to use RHS because this letter R, it is showing me that I am dealing with the triangles having the 90 degrees on them. Okay, so after that, we're going to conclude by saying AM, it is equal to MB at the end. So this is how we prove theorem number 1. You would recall that we are working towards the 5 marks, plus or minus 5 marks, by just proving it. Okay, just enjoy the video and make sure, guys, master the theorem instead rather of you cramming it, because you will need this theorem when you answer some particular questions. And also stay tuned, since I'm still going to take you through the converse of this theorem number 1.